Hey everyone! Today we're going to be talking about the Euclidean algorithm. First of all, let's review something called the GCD. The GCD, or greatest common divisor, of a and b is the largest integer that divides both a and b. The GCD of 36 and 12 is 12 because 12 is the largest factor that divides both 12 and 36. In the next example, 12 can be broken up as 2 squared times 3, and 8 can be broken up as 2 cubed. Both of these numbers share the factor 2 squared, and that is the largest factor that is shared between them. Therefore, the GCD of 12 and 8 is 4. When we have two prime numbers, like in the case below, we see that their GCD will always be 1. Since these two primes are different, the only factor they can share is 1, and that is also therefore the largest factor they share. But now, what do we do when we have really large numbers, like 1,287, and take 3,845? Well, this is when the Euclidean algorithm comes into play. So, I've illustrated a bit about how this algorithm works, but it might be easier to understand with an example. In general, when finding the GCD of two large integers, by using the Euclidean algorithm, we take the difference of the larger number minus the greatest integer multiple of the smaller number that is less than or equal to the larger number, and keep doing this until we obtain two small numbers, the difference and the smaller number, that we can easily take the GCD of. Let's illustrate this through an example. Let's use the Euclidean algorithm to find the GCD for 282 and 1084. We take the larger number, 1084, and now we have to find the largest integer multiple of 282 that is less than or equal to 1084. 282 times 4 is 1128, which is greater than 1084. 282 times 3 is 846, which is less than 1084. So from 1084, we subtract 3 times 282, which is 1084, minus 846, which is 238. For the next step, we take the GCD of the difference, 238, and the smaller number from the previous pair of numbers, which in this case is 282. So we take the larger of the two numbers, which is 282, and subtract from it the largest integer multiple of 238 less than or equal to 282. Since 238 times 1 is less than 282, and 238 times 2 is definitely greater than 282, we do 282 minus 238, which is 44. Now we take the GCD of the difference, 44, and the smaller of the previous pair of numbers, 238. So like before, we take the larger number, 238, and subtract the largest integer multiple of 44, which is less than or equal to 238. This is 44 times 5, or 220. So we do 238 minus 220, which is 18. Repeating the same process on the number 18 and 44, we obtain the difference of 8. Performing the same process on the numbers 18 and 8, we get the difference 2. And since the GCD of 8 and 2 is 2, the GCD of our original numbers is also 2. Here are some arrows illustrating this process a little bit more clearly. Let's do another example. Take the numbers 72 and 196. The larger number is 196. The largest integer multiple of 72, which is less than or equal to 196, is 144, 72 times 2. The difference of 196 and 144 is 52. Our next pair of numbers is 72 and 52. Since 52 times 2 is definitely bigger than 72, we take 72 minus 52, which is 20. Our next pair of numbers is therefore 20 and 52. 52 minus 2 times 20 is 52 minus 40, which is 12. So our next pair of numbers is 12 and 20. 20 minus 12 is 8, and the GCD of 8 and 12 is 4. So the GCD of 72 and 196 is 4. Let's do some practice problems now. If you want to do these by yourself, please pause the video here and then check your answers afterwards. For the first one, we take the larger number, 198, and subtract 168, since 168 times 2 would be larger than 198. The difference is 30, so our new pair of integers is 168 and 30. We take the larger number now, 168, and subtract the largest multiple of 30 less than or equal to 168, which is 30 times 5, or 150. 168 minus 150 is 18, so our new pair is 30 and 18. If you know the GCD of 30 and 18, you can actually stop here. We can easily figure out that it's 6, but you can also obtain this by doing more steps of the Euclidean algorithm, as shown here. For the second problem, we take the larger number, 174, and subtract 2 times 87, which is also 174. Because the difference is 0, and the GCD of 87 and 0 is 87, the GCD of 87 and 174 is also 87. For the third problem, we take the larger number, 2095, and subtract 398 times 5, which is 115. Our new pair of numbers is therefore 398 and 115. 398 minus 115 times 2 is 9. Our new pair is then 9 and 53. Since 53 is prime, the GCD of 53 and 9 is 1, which means the GCD of our original numbers is also 1. Numbers like this, whose GCD is 1, are often called relatively prime or coprime. For the final problem, we take 3,123 and subtract 504 times 6, which is 99. Our new pair of numbers is then 99 and 504. 504 is the larger number, so 504 minus 99 times 5 is 9. We now have the pair 99 and 9. Since the GCD of 9 and 99 is 9, we can stop here and know that the GCD of the original numbers is 9. Finally, if you feel like this wasn't enough or you'd like more practice resources on this subject or any other, please check out our website linked in the description box below.
Thanks for watching!